Hi, everybody, and welcome to this webinar hosted by Danfoss high pressure pumps. We are today going to talk about dust suppression for wood applications. And I'm very happy to see that so many of you have decided to join us here today. Before we start, just a few practicalities. You can see on your screen that there are different areas. If you have any questions during this presentation, please do not hesitate to use the opportunity and write questions to us in the Q&A part. Also, it's important to mention that the session here will be recorded and shared with you shortly afterwards. So you have the option to revisit what we've talked about and also share it with colleagues and so on. What you can also see on your interface is that there is a QR code. This you can scan with your mobile, and then you will get a 3D of our one of our products, which you can turn and zoom in on and play a little with. Also on the below on your screen, you can see this 3D model if you wanna see it on your PC. All right. So today we will be two presenters. There will be Hannu, my colleague, and myself. I'm Kent Mentz. I'm the product manager at Danfoss high pressure pumps, and I'm responsible for high pressure pumps for drinking water called PAH, as well as pumps for technical water or DI water, which is called PHT. On top of that, I also have a number of high pressure pumps that includes solenoid valves, relief valves, and check valves, and our Powerpack units, which we are going to look more at later during this session today. And then we have Hannu, my colleague, as mentioned. Hannu, could you shortly just introduce yourself to our audience today?
Yes, Kent. Hello, everybody from my side also. I'm sales responsible for HPP in Sweden, Finland, and Baltics, and I'm sitting in south part of Finland. I've been working with Danfoss HPP over 20 years now, and a little bit even more with Danfoss. Yeah, at the moment I've been working with these applications, what we are going to tell today, over 20 years. So I have got some experience of these systems already.
Absolutely. Thank you very much, Hannu. So, Danfoss high pressure pumps, who are we? Well, we are making different components. Of course, as the name says, our key component is our high pressure pump. And you can get that in different versions for different types of water, that being seawater, drinking water, and technical water, among others. And that goes into a number of different applications, as you can see here, from desalination to humidification, firefighting, and gas turbines, and of course also wood, as we are going to talk about today. Now, if we focus on wood, we are not a newcomer here in that business area. We've been around for more than 20 years, and we have more than 1,000 installations around the world where our products and our Powerpacks are sitting and working on a daily basis. We, as you can see here, the picture shows an NVC Powerpack unit, which is one of our key products for this industry here. And it's a very flexible offering that can be fitted to a lot of different needs. And I'm going to come back to that, of course, later. But first, I think we should just have a look at dust suppression as an application. And I know, Hannu, you would like to tell us a lot about this.
Yes. Yeah, in this left-hand picture, it's an old picture. I have taken it many years ago. You can see how awful the situation can be in the sawmill. These white spots here, they are not snow, they are just dust which is dropping down or floating in the air. I always call this that it looks like this when it's dusting. So basically, this situation, if you have a similar situation in your own application, please take a contact to us immediately. But anyway, the purpose of dust suppression is to keep dust level safe and comfortable for staff. This is a legality and welfare matter. And also prevent dust to reach the level where the ignition is happening, because after this kind of situation, it will cause exploding of area or production facilities. They are still rather common in different places, unfortunately. Also, there's some positive side effects, which, for example, cooling during summertime and increased comfort during cold and dry winter seasons. Many places, for example, when you have a lot of lumber inside in the production facilities, very dry atmosphere causes the tracking of the wood. So it's also good for materials, not only for humans. One practical benefit is also that if the humidity level remains between 40 and 60%, it has it's a positive impact against viruses. So they are not so active when the humidity level is reasonable level. Basically, there are two different systems or technology to remove the dust. The oldest one is the fan systems, and our systems is the second one. Next slide, please. This is example how the water acts in different technologies. If we are discussing of low pressure against high pressure. If we are taking 1 liter water, spraying it out through the good nozzle, and in low pressure systems, which means 4 to 6 bar, the droplet area can cover roughly 30 square meter. However, if you are choosing high pressure, taking same amount of the water, 1 liter, spraying it out, the area of the droplets covers from 180 to 200 square meters. So it's 6 to 7 times larger area. And we are still discussing of same amount of the water. So this water, if you are using all water for the process, you are avoiding side effects like damping and all these kind of things. So it's very effective way to use water. Next slide, please. Here we have an animation which we have made just to show how the systems or droplets works in the real life. There are big droplets and small droplets, and you can see how they are working in the air. And I think that this animation tells more than 1,000 words. So please, Kent.
Yeah.
hopefully this gives some ideas how the system works when we are discussing of small droplets against dust. You can see also in the right hand the link to this animation, and hopefully you can use and show it to others later on. Okay, next slide, please. Here we have a typical saw line, one machine, and you can see here there are some nozzles spraying upwards, and they are just binding dust which is floating above the saw machine. It's very important actually that you try to bind the dust wherever it generates. So inside the saw machine, it's very useful to have a dust binding system also. So the most of the dust doesn't even start to fly around the production facilities. Also, it's important to use right size of the nozzles and place them the right places, not causing any extra problems with the water mist. But basically, when this system works well, you doesn't even notice that there's a water mist coming out. Next slide, please. So in this picture, you can see there's also nozzles spraying upwards, and these kind of applications, when you are moving lumber from place to another, there's a dust after sawing process on the surfaces, and every time when the lumber is hitting somewhere or it's transferred, the dust starts to fly. So placing these nozzles in the right places, you can easily prevent this flying dust. But it's also important when you are placing these nozzles or planning where to place them to understand how the airstream is moving inside the production facilities. Because if the nozzle is installed in the wrong direction against the airstream, this water mist doesn't go in the right place. So it's very important to understand how to and where to put these nozzles. All these kind of processes like sawing, cutting, grinding, they are producing these flying dust, and by this way you can easily control the dust levels inside the production facilities. Next slide, please. This is a landfill application, but it can also be inside the sawmill, anywhere in the place where dust is coming. This is a conveyor dropping down to the next conveyor some materials which is typically dry and includes a lot of small particles, which of course starts to fly when they are falling down. Also in this picture you can see the nozzles backwards. It's important that it's right size, spraying in the right place, so then you are able to avoid damping problem. Also, it's important that the nozzle is big enough, otherwise you get the dust flying outside of the water spray. So next slide, please. This is one application of sorting. Also very typical, every saw line has this kind of production part. In this picture, actually, it's difficult to see, but there's two nozzles. One is behind this white area where we are stating this high pressure water mist, and other one is about 2 inches to the right side of this text. So you can see, you can hardly see the water mist there, but this is the right way to make it, because you can hardly see it, but it works. So the right amount of water mist is a perfect solution. Next slide, please. So when we are discussing of these technologies, fan technologies or high pressure water mist technologies, there are certain features. For example, equipment cost. Fan technologies, for example, the invest is higher. There's much more materials. And for example, duct size, for example, their diameter is easily 160 millimeters up to 400 millimeters. But in high pressure systems where we are using pipes, the typical diameter of the pipe is from 10 to 12 millimeters. So it's relatively much smaller. So it means that less materials. It's also power consumption. Our systems, they are using from 2 to 4 kilowatts, and compared to big fans, it's nearly nothing. So the payback time is much shorter. Also the footprint, if you are installing the fan system, it needs more space. And for example, in existing facilities, you need pre-planning, and also during the installation, I think that production is rather difficult because of the need of space. But instead, if you are installing these high pressure systems with the small pipes, you can easily do it during the work shift. And also it's easy to install because it's a flexible installation, small hoses for bushings, for example, or even without any holes if you are using hoses, for example. So you can easily go through construction areas by using these features. So basically it's a lot of benefits if we compare these high pressure and fan technologies and especially in the existing facilities. So the next page, please. In this page, there are some dust levels and safety limits. Dust has various negative influences on people and can cause diseases of the respiratory systems, so for the lungs, for example. That's why we need to find every possible way to decrease, especially flying dust. The principle of dust control works as follows. The water mist droplets that are atomized into the fine mist combine with the dust particles in the air and make them heavier and bring them down. So basically the same as you saw in the video or animation a little bit earlier. Also there are different kind of or different size of the droplets, as there are also different size of the dust particles also. But anyway, by this way, when you are producing a lot of small droplets in the air, it's much better possibility the droplet to hit the dust particle, and together they are more heavy and falling down. The size of the water drops is an essential criterion for the quality of the dust control. It's essential that the water droplets are similar in size to dust particles to allow them to adhere to them. It means that in this picture, for example, in the right hand, you can see that if the water droplet is rather big, it's just raining down, and the dust particles are just avoiding to touch this droplet. Typically, when we are discussing of flying dust, the size of the dust, what they are measuring nowadays is 20 micron or smaller. And also the systems what we are using with 70 to 80 bar, we are about the same level of the size of the droplets. That's why these fits perfectly together. So the thumb rule is the higher pressure, the smaller droplets, the better efficiency of the dust binding system. Also, there's a risk, this explosion. There are some categories. You can see there's one example here. But anyway, if there is some ignition, you have enough dust in the air, and it comes some flames. It's sure that you will lose your production facilities or has a big stop of production. It will be damaged badly. It's also that the regulations that the value for the inhalable dust fraction has been earlier 10 micrograms per cubic meter, but the value will be decreased, and even it is decreased already to 2 milligrams per square meter or cubic meter, sorry, per 8 hours shift within EU. It means that if you are staying inside the production hall or production facility, for example, 8 hours, the level can be highest 2 milligrams per cubic meter. Above this level, wearing the mask is mandatory. And I can say that it's not nice to wear the mask whole 8 hours in the production area, especially when it's hot or bad place. Yeah, but basically I give the shift now to Kent. Please, Kent.
Yes, thank you very much, Hannu. So I'm gonna talk a bit more about our product offerings that we have for the wood applications. As already shortly mentioned, our main offering is our NVC unit. As you see here, I'm coming back to that in a second. The three other products that we have listed up here are our key components. Mainly our high pressure pumps. They are built on the positive displacement principle, meaning that the flow is directly proportional to the speed or the number of rotations of the shaft. So the faster it rotates, the more flow it provides. It's made of stainless steel, making it highly reliable and gives a very long service life. It is so that as standard, we say that there can be up to 8,000 hours in between service. But what we also see from real life wood applications is that as long as the filtration is in place, these units, Powerpack units, they can run for up to 20,000 hours or more in between service inspection. The pumps are not lubricated by oil. They are only lubricated by the media that the pump is operating in. So there's no oil service, which also reduces the maintenance. Besides this, we have our different kinds of high pressure valves, among others our solenoid valves, open closing valves. They're also made of stainless steel. They're very compact, and the maintenance on them is very limited, and it's easy to conduct also without having to remove the valve from the line. They can either be installed directly on our Powerpack unit or in in the application wherever it fits. Finally, we also have different types of nozzles made of stainless steel in a number of various sizes to fit to the right need, as Hannu mentioned. And they are also available with an anti-drip function. For now, let's just focus a bit more on our NVC Powerpack unit, which is our wood concept product, or the main offering we have. It's built on one concept where we have 5 basic sizes, and on top of those 5 sizes, we can customize the unit depending on your need. The 5 sizes, they are from a physical dimension perspective all the same. They have the same physical footprint, but the flow range varies. I just want to share my screen, so just hang on a second, and I will jump to our 3D model here, where you can see the unit a bit more. So we have here our tank. It acts as a buffer. Inside, the pump is sitting well protected and fully submerged into water, and it's actually an ideal location for the pump, which is also one of the reasons why we see these very good and long service intervals. And I said, as long as the filtration is in place, we have the filter here, they can run for more than 20,000 hours typically. Also, the tank acts as cooling for any flow that may be recirculated, that the pump is creating, but which is not used by the application. Then it's actually recirculated back via the filter into the tank. Right. Then we have here, this is our Powerpack valve, and that can be used to recirculate flow back to the tank if it's not needed by the application, and thereby it actually provides a very broad flow range for this one unit. We can recirculate up to 90% of the water that is being pumped. We can recirculate that back to the tank without heat being generated in the water. What you see here, that is then the high pressure outlet that's either going to our solenoid valves, which can be mounted here on the frame, or they can sit in the application itself somewhere. Over here, this part here, that is our filling system. Here you have the water inlet, water supply, and as mentioned, we have the filter here. It is 10 micron absolute filtration, and as long as that is installed, we see very good performance and lifetime of the unit itself, and that provides a long service interval. Over here you see a level and temperature measurement and an air breathe. Whoops. All right, let's get back to the presentation. But I mean, you have access to this 3D model yourself also, so you can have a closer look if you want to do that. As mentioned, The unit comes in 5 basic sizes, which you see here in the table. It comes either as a constant speed version where you have the electrical motor installed. If we take the American units, the smallest unit, when it's running fixed speed 1800 RPM, is between 0.57 and 4.84 gallons a minute. Of this value here, as said, 90% of that can be recirculated without the water being heated up. It passes through a relief valve and then returns via the filter back to the tank. So that in itself actually gives a broad flow range. Another option is to install a frequency converter drive on the unit itself, also to control the actual speed of the motor, and in that way to control the flow. That's also an option. But in many cases, we just see that the constant speed is more than enough in most applications. So as mentioned, there are some additional options that can be chosen to customize the units. We've already talked about the pump size to fit to the right need in the application. Besides this, there's also the media, whether we are talking about tap water and drinking water. In that case, it would be our PAH pump, or if the application is a DI water / technical water application, then it would be our PHT pump, which would be sitting inside the tank. We have different motor sizes, of course, depending on how much flow and what pressure is required. And then we have our filter sizes that can be chosen, which filter would be the right one for you. In addition to this, as mentioned, we have the solenoid valves. They are called VDHT, our solenoid valves from Danfoss. They can either be installed on the frame or in the application. And on the frame itself, we can have up to 12 valves installed and controlling the same amount of zones. Finally, it's also possible to get the NVC Powerpack with a control system from Danfoss. It's also possible to get it without and use your own control system. This gives the flexibility that the unit can be installed both in new installations where you might have a control system yourself you want to use, or in existing installations where you might not have that option, and then we can provide a control system for you. So that's both an option. If we have a look here, as Hannu mentioned, we have a very compact unit with a very small footprint. So, and at the same time, if we look on the right side, here you get a schematic of how the unit is looking and how it's made. We have here the pump sitting in the tank and the motor. And out here we have solenoid valves controlling the different zones in the application. Here we have our Powerpack valve. So in case the pump is producing excess water, which you don't need in your application, it will be relieved via the relief valve in the Powerpack valve, via the filter and back to the tank. It's also possible to use the solenoid valve we have here sitting in the Powerpack valve to recirculate water in case you have your application running, but for the moment don't need water in a whatever minute or two, for instance, but then you need it afterwards, and therefore it makes sense to keep the pump running, and then you just recirculate the water. So that's also an option to use it in that way. Right, to try and sum this up, we have this one unit, the NVC unit, which can be customized in the way you want. It's made up of 5 different flow sizes, but it's all in the same footprint, physical footprint. Now today we've talked a lot about dust suppression, and it can definitely be used for dust suppression, but it can also be used for other applications within the wood area. For instance, when we are talking about saw blade lubrication, and also when we are talking about lumber drying in drying kilns, as well as for heat treatment applications. It's all the same within the same unit that can handle this. We have a very high uptime, or the unit has a very high uptime. As mentioned, it can be. We have seen many examples where it's running more than 20,000 hours in between service intervals. And as Hannu mentioned, using high pressure water mist is highly effective compared to, for instance, low pressure or the fan or vacuum technology. So only with a small amount of water, we can cover a very large area, and also the smaller droplet sizes, due to the higher pressure, is better at capturing and binding to the flying sawdust, and thereby making it heavy and fall to the floor. So it's a more effective way to combat the flying sawdust. The size makes it very easy to fit into tight spaces, both when we are talking about new installations and also retrofitting existing ones. And due to not only that the unit itself is small, but also the amount of flow needed is less. Also the piping is smaller, and therefore also making it easier to fit into, for instance, existing saw lines. Good. All of this is made using well-known Danfoss technologies that have been in the market for many years, and they have been proven in the field. Good. So that was what I have prepared so far. So let's move on and see. I can see that we have some questions already that we can go through. There's one here. What do you need from your client to calculate the size of a dust binding system?
If I take
Hannu, is that something? Yeah, please.
Yes. There's certain information which is needed, and your local suppliers can do it. And first of all, how much production area you have, what kind of climate you have, what is the airstream, all these kind of tiny details. It's not rocket science, but for example, where to place nozzles, what is reasonable pipings, on all these kind of issues. It's rather easy when some professional is doing. It's really not rocket science. But basically,
okay, thanks.
few facts.
Yeah. And then we have another question. How long are the working hours of such a system? So as mentioned, we have seen that these kinds of systems can typically run up to 20,000 hours or more, even though that we as a standard say that for the pump, we are saying 8,000 hours in between inspections. But when you have your filtration in place on the unit, and with the pump sitting in the tank well protected, it can easily run 20,000 hours or even more. Then we have a question more. Do you also have solutions or products for fire suppression of such a plant using high pressure water mist? Of course, the NVC unit, when it's spraying out water mist for dust suppression in such an area, will have a certain positive effect on reducing the risk of fire, but it's not a fire suppression system as such in itself. We do sell pumps and valves for fire suppression, but we are selling them as components and not as systems as such. It's not built into a skid, for instance. Do you want to add something, Hannu? Or?
Yes, I was also thinking to mention that because we have only these 5 different models and 2 pump size, basically frame size. In the retrofitting cases, if you need more flow, for example, it's rather easy to change a bigger pump. There has been some cases where the customer has wanted more flow. And also the maintaining issue that if you have a certain units, even you have several units there and they're in different show lines, for example, in different places, it's easy because you only need very few spare components to maintain the units. So it's also very user friendly for the end user and maintenance
Absolutely.
persons.
Exactly.
Yeah.
We
and also the structure.
Go on.
Yeah.
Go on.
And also the structure, as Kent mentioned, that it's very, let's say, robust. So it's a perfect solution for this kind of environment. There's a lot of things happening all the time, and they are typically quite, let's say, not so clean areas.
Yeah, exactly. Okay, I can see we have another question. What type of water do we need for this system? Can the regular drinking water / town water be used, or do we need to supply special water? No, such a drinking water can be used, and we see that in many applications. So it's just a matter of one or the other type of pump that is needed, but we can cover both normal tap water or technical water, DI water, that type of thing.
Yeah, and the most important is to keep the filtration level okay.
Exactly. Good point. And then, we have another question. What other areas in the wood industry beside dust binding could be a typical application for water mist? Okay, so yeah, so beside dust suppression, these units, or NVC units, and high pressure water mist in general, we see applications for saw line applications, where you are cleaning and lubricating the saw blades, and also for when we're talking about lumber drying inside drying kilns. Water mist is very effective. And also when we're talking about heat treatment for wood.
Yeah, and I can mention that we have debarking machines. For example, pine in the springtime, it produces a lot of dust. And also inside the debarking machine, you can very clearly see that it keeps resin away from the machine, especially on the knives of the debarking machine. Also, when they are making plywood, they are using this kind of system for moisturizing, that the plywood is even moisturized when they are gluing them together. Some applications even they have to, when they are gluing wood material together, they need to have a control of the humidity level, because it makes the process faster if you have a humidity level high enough. So it speeds the process.
Maybe we can just take, there's a question related whether the same kind of system, NVC system, can be used for the different types of wood applications. And if I should answer that, then yes, the NVC unit can be used, of course. Definitely it can.
Yeah. For example, this dust binding system, it's not only wood. We have also applications in concrete areas, and a lot of different kind of this dust applications. But we have noticed that in wood, this works very fine way. Nearly every
That's true. I mean, it's
different kind of processes.
Right. Yes. Where we have dusty environments, it can be used. All right. We have another question here about if we can compare high pressure to low pressure systems. What about the advantages? You want to take that, Hannu?
Yeah.
Fine. Thanks.
As we told that many years ago, I get questions from people. They have tested low pressure systems with different kind of applications, and most of the cases the systems didn't work. And when we came to the market with high pressure systems and with the small droplets, they were wondering why it works now. They did get it to work earlier. I just mentioned it's a difference of the pressure, because we are splitting the water into so tiny parts, so tiny droplets, that it takes this part of the processes. For example, lubrication, dust binding, and all these. If you have big droplets, the gravity of the droplets has a certain impact for the process. So most of the water is, let's say, with these words, it's raining down on the floor.
Right.
So the tiny droplet is the key word. Yes, it's a key.
Exactly. So that turns into a mist that is more moving around or flying around in the air itself, rather than just raining down.
Yes.
That's right. Okay.
And also in the past, when they were using water lubrication, for example, in the saw lines, they have to use rather much water to reach the same effect what we have, this very, very small amount of water. So they have a problem with damping and also floating under the saw lines.
Exactly. Good point. Okay, I think that was the last question, at least that we have in our inbox so far. If there are any more questions, do not hesitate to send it. Otherwise, you can always reach out to us also afterwards, either to Hannu or myself, or to one of our contacts that we have listed here. So if there are no... Okay, I have a question here coming in about the noise level of the system when it operates, if it's measured. Do you know if we have any information at hand?
I don't know. I don't know if it's any official information. Basically, in the production areas, there's so much back noise, you can't even recognize that the unit is working. Many times when I have been visiting areas, I have to test it, is it working or not. And also because in these kind of cases where we have pump in the water, it's isolation against the noise. So basically they are rather quiet units.
Right. Right. They're not the noisy units in a saw line. For sure not.
No. Yeah, they are more quiet as compressors and so on. These kind of systems.
Yeah. All right, Hannu. Thank you very much. So as said, if you have any more questions, please do not hesitate to reach out to us. Also after this event here. And with that being said, I would like to thank you very much for participating. I hope you found it valuable and that you will reach out to us. We'd like to talk more to you about our different offerings here. So thank you very much, and I hope you'll enjoy the rest of your day.